Welcome back to the Green Chemistry Education webinar series hosted by the Green Chemistry Commitment. My name is Kate Anderson, and I am the Director of Education here at Beyond Benign, a nonprofit organization dedicated to green chemistry education in K-12 through higher ed. This webinar series is designed to highlight relevant topics in green chemistry education for faculty and students who are looking to adopt green chemistry in their courses and programs. As a reminder, we are broadcasting live and recording this session. Therefore, all attendees are in listen-only mode, and all lines are muted. If you do have a question, then please type your question into the question chat box on your control panel for the moderators to view. We will respond to as many questions as we can after the Dr. Brush presentation. The recording will be posted on the link you see in the welcome box. And on this PowerPoint slide, any supporting documents, such as presentation slides, will be posted at that link as well. For those of you who would participate in social media, please connect with us on Twitter or Facebook. We would love to hear some live tweeting going on during our webinars, so join us if you'd like. Thank you for joining us for this webinar and for taking part in the discussion. This webinar is being brought to you as a part of the Green Chemistry Commitment Program, which is a consortium program aimed at transforming chemistry education, expanding the community of green chemistry practitioners, growing departmental resources for those looking to adopt green chemistry, improving connections to industry, and affecting systemic change in chemistry education. The program is a voluntary, flexible program for adopting green chemistry student learning objectives and for promoting the work that you are currently doing at your institution that can serve as models for other institutions to get involved with green chemistry. You can find more information on the link at the www.greenchemistrycommitment.org, or you can email Amy Cannon, the Executive Director of Beyond Benign, at amycannon at beyondbenign.org. As a part of this webinar series, we are going to be giving away a green chemistry book at the conclusion of the webinar. We will announce the randomly selected winner from our list of attendees at the end of the webinar, and we will send the book to you directly. The winner will receive an email from us requesting your contact information immediately following the webinar. At this point, I would now like to introduce our speaker, Dr. Ed Brush. Ed Brush is a professor of chemistry at Bridgewater State University and coordinator of the Project Green Lab, an outreach initiative engaging students and educators in projects that apply the principles of green chemistry to solve real-world problems related to the use of chemicals in society. Ed is an advisory board member of the Green Chemistry Commitment and serves with the ACS Green Chemistry Institute group that is developing a green chemistry education roadmap. Ed also works with Dr. Jane Wissinger from the University of Minnesota in coordinating green chemistry education symposia at the ACS national meetings. Ed received his BS degree in chemistry from King's College in Pennsylvania and PhD in bioorganic chemistry from Penn State University. So Ed is going to be joining us today to present on green chemistry, equal social and environmental justice. So I am now going to turn, oops, sorry. I'm going to now head this over to Ed. Sorry. Here we go. Here you go, Ed. I am changing controls over for you.
Okay, Kate, thank you very much. Is my voice coming through okay?
Yes.
Okay, fantastic. Well, thank you very much. And let me just thank Beyond Benign and the Green Chemistry Commitment right off the bat. It's just been a pleasure to have worked with you and with Amy and everyone else there for many years. And also just being part of the Green Chemistry Commitment and getting to meet other green chemistry educators has just been a wonderful experience for myself, for my colleagues and my students over my career. Greetings to everyone. It's great to have this, for me, a very unique opportunity to give a webinar. I do teach a flipped classroom in my organic chemistry class, so sitting in front of my laptop staring at a PowerPoint and talking to nobody is, I guess, something I've been used to over the past year. If you want to contact me, you see my email address on the front screen. I am also on Twitter at GreenChemEd. And also, over the course of the webinar, you all have the opportunity to type in questions. So please feel free to do so. I will be stopping or pausing to look at questions about halfway through the discussion and address some of them at that time. For those of you who are not familiar with Bridgewater State University, we're the largest state university in Massachusetts. We're a teaching university. We're not part of the UMass system. And we're located about halfway between Boston and Providence in southeastern Massachusetts. And it is a balmy 75 degrees here. It is a beautiful fall day in New England. I wish you all were here. So I have an outline. You can take just a brief look at this. I do this to set a good example for my students when I have them give presentations. I've got my talk broken up into two parts. The first part will focus on the role of chemistry in society, the unintended consequences of chemical exposure, and some of the resulting issues related to social and environmental injustices. At that time, there will be a change in perspective where I will pause for some initial questions and then move on to looking at green chemistry and what its impacts can be in terms of dealing with some of these issues related to social and environmental injustice. Talk a little bit about the next steps, and then I will have some homework questions for everybody. I'm also in this unique position of being on sabbatical right now until the end of the year. So this will be a great time that if any of you would like to continue this conversation with me, either by email, by phone, or even a face-to-face visit, I'd be very, very happy to do so. I'm really happy to have this opportunity to have this conversation about the issues of social and environmental justices, and hopefully as a group see how we can work together in understanding what these issues are and also how green chemistry can have an impact. So for goals and objectives, my goal in this webinar is just to continue building on the enthusiastic discussions that began at the 2016 Green Chemistry and Engineering Conference out in Portland, Oregon, where we had over 70 participants, and they were all from a variety of different disciplines. They were not all practicing chemists. And another part of the goal is just to establish a future direction for this discussion. So it'll be great to get input and feedback from those of you who are participating in this webinar. The objectives here are not going to be accomplished at this webinar. These are more long-term. So establishing the dialogue and establish dialogue and collaborations between the green chemistry community and other disciplines. One of the things at Portland, Oregon, at the Green Chem and Engineering session, I was really surprised that approximately or over half of the participants were not what I would call practicing chemists. They were from other fields and other disciplines. So there is a lot of interest in this topic beyond the chemistry enterprise, and I think that's an opportunity that we really need to take advantage of. At some point, I'd like to look at the SWOT analysis of these issues: strengths, weaknesses, opportunities, and threats. I'm hoping to have a panel of experts to discuss this at the Green Chem and Engineering Conference in 2017. And certainly for me, and I'm guessing for others out there, to build our confidence so we can better discuss these issues, or maybe even better, to build collaborations to help discuss some of these issues. And I think most importantly is a little bit discussion on how we might be able to develop some educational resources. So to frame the dialogue, I have a few preliminary questions here. I'm not going to go through these, but you'll be able to take a look at these and think about them. I would really love to hear your feedback on some of these, your responses, either by email, or if you have a great answer for one of these, go ahead and type it in and we can take a look at it either halfway through or at the end. And this will help in the future planning for how other discussions and dialogue on this topic that might occur. So just looking at number one, why hasn't this issue of the social injustice of chemical exposure received more attention? From my perspective, it's just being out of my comfort zone. I've also, after the Green Chem and Engineering Conference in Portland, I also see that there is a gap between understanding the issues and the connecting that with the promise and the potential of green chemistry to offer solutions to social inequities. This has certainly been out of my comfort zone. I'm certainly much more comfortable discussing the research that I have going on in my lab or my classroom or my outreach work. Number 3 and 4, why are you here? What do you hope to get out of this webinar? Was it successful? These are, I guess I would call this an informal assessment or feedback. So any input you folks can give me on those would be very useful. And I think number 6 for the educators is very important. How do we see this issue of social inequities related to chemical exposure and the potential of green chemistry fitting into our own teaching, our research, and also our outreach efforts? All right, so let's talk a little bit about where chemistry fits in society. So here's a photo of Lamont DuPont Copeland. He's the 11th president of DuPont in the early 1960s, and he was responsible for the major growth and expansion of the company both in the United States and overseas. And this is a picture from the cover of Time magazine, November 27th, 1964. We see this complicated apparatus, almost looks like some eyes, a smiley face here. Liquids are going through here, changing colors, and producing a lady's shoe. So it almost seems as if this is the heyday of chemistry, where chemists with this very trusting face, and yes, the fact that it's a white male wearing glasses, but not a lab coat, this trusting face producing a product that society has a need for. And it happens to be pink, so the color has something to do with it. It may be some plastics in there, adhesives. These are all things, of course, that came through chemistry. We know that chemistry is everywhere. Chemists provide the chemicals and the chemical products to meet the needs of society, and there have been numerous beneficial impacts from medicines, cleaning products, cosmetics, agriculture in terms of fertilizers, chemicals, herbicides, and of course plastics. The chemicals in the plastics provide the functionalities that consumers want, the color, whether they're flexible, as well as other things. The problem is that we have admittedly made some poor choices in the chemicals we use, and these have resulted in unintended consequences. And in terms of plastics, all we have to do is think about BPA, which is a known endocrine disrupting compound. And more than that, there are other issues, other unintended consequences that we observe. For example, DDT. This was used a lot in the 1950s, 1960s. There were songs written about it. My grandfather, who was an immigrant to the United States, he grew potatoes on Long Island in New York and used DDT to fight the potato beetle and other insects and pests. And I can remember as a young child watching him mix these huge vats full of DDT, pouring these bags of this white powder. The dust was everywhere, getting all over him, not wearing a respirator because he didn't know, sticking his whole arm into the vat in order to stir it, essentially using his arm as a stir rod. And my grandfather passed away from bone cancer, most likely contributed through his use of DDT. The well water in many parts of eastern Long Island was contaminated, and filtration systems had to be installed in many homes that used well water, and there were numerous cancer hotspots. We know that some of these chemicals, the imprints, can be passed on from generation to generation. Other unintended consequences, such as the methyl isocyanate disaster in Bhopal, India. So here's the problem. We have made, again, poor choices in chemicals that we use in making these products that consumers have wanted or needed, resulting in unintended consequences on human and environmental health. And we've gone from that rosy picture of DuPont in the early 1960s to the new face of chemistry, Walter White from Breaking Bad. The show plays into our preconceived notions that chemists are mad scientists and that chemicals are bad for you. Also, just like DuPont, still a white guy wearing glasses, but not as friendly a face. So we have some work to do. So let's look a little bit more at these unintended consequences, in particular the social and environmental injustices of chemical exposure. So at BSU, social justice is one of our strategic priorities, and it's been integrated into our curriculum, more recently, well into my research group and also into my teaching. And I've had this very fortunate opportunity to have worked with colleagues from our sociology department, from political science, from psychology, as well as students outside of chemistry. It's certainly given me a much better appreciation of what their research is all about, related to social justice issues. And on the other hand, they've been able to see how green chemistry can play a key role in avoiding or correcting these unintended consequences. So just in summary of where we are right now, chemicals are part of our everyday lives. Okay. Everyone in the world is exposed to manufactured chemicals. We've made poor choices. These are the unintended consequences. There is a disproportionate exposure based on gender, race, socioeconomic status. Children are the most vulnerable. And we do have a need, more than ever, for collaboration, research, education, and activism. And I'm hoping that the students in the audience are seeing that last word, and we'll take note of that. Let's look at some definitions. At the Green Chem and Engineering Conference in Portland, Mary Kirchhoff was one of the speakers at our session. She's from the ACS Education Division, and she just framed our discussion so nicely. She gave a very brief overview of some of the definitions of social justice, promoting a just society by challenging injustice, valuing diversity, justice that follows the principle that all individuals and groups are entitled to fair and impartial treatment. So I think here's an area where we probably need some work as green chemists and as educators, and even students can play a role in here, is how do we relate social justice issues and define this in the context of chemistry as well as green chemistry. Environmental justice is a little bit better explained. EPA has a site on environmental justice, and there's a lot of information there that's very useful. But the bottom line is all people, independent of race and social economic status, are entitled to clean air to breathe, safe water to drink, and to live in healthy communities where they can raise their families, work, learn, and play. Now, probably one of the more beneficial things that I've done over the past several months is learn how to use Wordle and to develop a word cloud based on documents that I had come across related to social and environmental injustices in chemical exposure. And this word cloud, a lot of things came out here that were really quite relevant to this discussion. For example, we see chemical, we see hazardous exposure as being quite prominent, and we notice disproportionate and we see vulnerable. We see low income, we see communities of color, we see indigenous populations. And I think something that's of particular made me feel pretty happy to see was the fact that green chemistry was showing up prominently, because a number of these articles and papers I came across were actually mentioned green chemistry as a way of addressing some of these injustices. But a couple of other words and terms pop up here. People, peoples, communities. The issue that we're looking at here impacts large groups of people. It is affecting their quality of life and on the future generations. So it's really looking at the sustainability of society. So that also helps, it's just helping to frame the importance of this issue. And from a green chemistry perspective, I think we can play a very important role in looking at how we can address some of these. So let's take a look now at just some examples from the U.S. perspective. Okay, these are just some headlines that I pulled, from EHN. That's Environmental Health News. That's a good source to get some of this headline information and then kind of use that as a route to get into the primary literature. So in the United States, we have pollution in our inner cities. Particulate emissions resulting from the burning of diesel fuels, from trucks, some automobiles. If you happen to live or work near a railroad yard, if you happen to work near docks where you have shipping coming in, working near or living near an airport. Okay, particulate matter is having an impact on the health of people living in inner cities. From an agricultural standpoint, agricultural pesticide exposure has been resulting in farm workers experiencing more chemically related illnesses than in any other workforce. Also from the U.S. perspective, we have the water crisis that is ongoing in Flint, Michigan, and the last time I had checked, more than 8,000 children had been exposed to elevated lead levels, some of these quite elevated. We also have hazardous waste sites, Superfund sites. Many waste sites do tend to be disproportionately located in or near non-white and low-income communities. This elevates health risks and also decreases property values. This happens to be a map that overlays Superfund sites with tribal lands. And the perspective, of course, has to relate to the impacts on children. These, of course, are the most vulnerable members of our society. Children in the inner cities. And again, these are some more of the headlines I pulled from Environmental Health News. Children exposed to the particulate matter from diesel exhaust have higher risks of respiratory disease, higher risk of asthma. Not only risk, but this is actually seen in medical documentation. This results in poor school attendance as well as poor school performance. And I've become also interested in looking at caffeine in children's foods, not just energy drinks, but caffeine appears to be creeping into foods that are targeting even younger generations. And caffeine powders can be purchased on the internet. These target kids, usually athletes at the high school level, and these caffeine powders have resulted in deaths. And even recently, I came across a crowdfunding site for caffeinated toothpaste. So the impacts of chemical exposure on society are affecting people disproportionately, and also I believe we're seeing a disproportionate impact on children, a negative impact on children. There's also an international perspective here. This past June, the United Nations Sustainable Development Goals went into effect, What we have here in these goals is a universal call to action to end all forms of poverty, fight inequalities, and tackle climate change, and ensuring that all people enjoy peace and prosperity. And as you look over these goals, you will see that several of these have a direct connection to what we can do or what we can contribute as chemists and green chemists. Number 6, clean water and sanitation. Number 7, affordable and clean energy. Number 13, climate action, as well as many others here. Now, also from an international perspective, this summer, Bridgewater State University had this very unique opportunity where we hosted a group of 25 young African leaders as part of the 2016 Fellowship for Young African Leaders Mandela Washington Fellows Program. The Yali Fellows participated in a 6-week academic and leadership institute. The goal was to help young African leaders develop skills and networks to build their countries and their communities. And I had a chance to meet with the Yali Fellows for 90 minutes, and we had a discussion on the social and environmental injustices occurring in Africa, in terms of how chemical exposure is impacting the people of their different countries. And they also had a chance to hear about green chemistry. I would say that most of them had never heard of green chemistry before, even though there is green chemistry in some of the universities in Africa, and heard a little bit about how green chemistry can play a role. Hopefully these young leaders will rise up and become politicians, become education leaders, and we'll have a door open where we can connect with them as educators and also as researchers. So I got a chance to learn about some of the chemical exposure issues that are occurring in Africa. The first that I like to summarize will be air pollution. This is a terrible problem in many of the cities in Africa due to the burning due to diesel engines, due to very poor regulations on quality control of the automobiles. Also power generation from the burning of diesel fuels, the burning of coal. And most recently I became aware of indoor air pollution because many people who do not have access to cleaner energy are burning charcoal and wood in their homes. And this is resulting in high incident deaths due to indoor air pollution. Here is a map that shows indoor air pollution deaths per million population. Notice very low here in North America, but Africa has some of the higher incidences of deaths per million population, somewhere between 400 and 610. So air pollution is certainly a very large issue in Africa. There is non-existent monitoring in the cities, and even where the monitoring stations do exist, they are not operational. Mining is another issue that is causing both social and environmental injustices in Africa. This we've got to be a little careful of, because this really is a delicate balance of economics and also the environment. So I think many of the listeners have heard about the endangered element. So these are critical elements that are needed for many areas of our technology, but they are either very rare in the Earth's crust or they are difficult to extract from the Earth's crust. Unfortunately, in at least our society, these play an important role in our modern electronic devices, including our smartphones. Got my smartphone sitting in front of me in the stopwatch mode, and I'm thinking, gee, I'd have a tough time, turning this away and not using it. The elements, these endangered elements, not as easily available in the United States. China is a supplier, but we don't exactly have the greatest relations with them. However, recently Africa is being seen as a possible supplier, or as a current supplier of some of these endangered elements. And in Africa, the mining practices do not have the same type of regulations we have here, resulting in environmental impacts. And young men who are looking for employment, they're paid pretty well by Africa standards to work in these mines, which do not have the type of safety regulations we have in the United States. And there are reports that children are being employed. Some of the access holes do not have to be drilled as large for children to enter them, meaning, of course, that less cost to those who are running the mines. So this is a difficult situation here, because it is a delicate balance between the economic benefits of these rare earth elements and how they're impacting people as well as the environment. And I'm hoping that the social and the environmental injustices are obvious, because these metals are going into the products that are being used in society and many other parts of the world, including the electronic devices that are sitting on my desk right in front of me now. So the purpose of this initial part of this webinar was to kind of set the stage in terms of understanding that there is an issue related to social and environmental injustices connected to the exposure to hazardous chemicals. A few examples, I'm sure that there are many more, but this is a good time to change the perspective, and I'll ask Kate if there were any particular questions that might have come up at this stage.
Hey, Ed, thanks. If there's any questions from the audience, we'll give, just a little chance for you to type it in and go ahead and send it over. Otherwise, we will keep going and address questions later. I do have one question for you, Ed, and this just came in. So related to, and here's actually another one. This is a good question. So have you checked out the EPA's environmental justice map?
I am aware of the EPA environmental justice maps. I have not dug into them myself. One of the topics that I mentioned a little bit later on in terms of the next steps is, what other databases are we able to mine for additional data? And I hadn't even thought of mentioning that, so I'm glad that that came up. It's an excellent question, an excellent point to make.
Great. Well, I also think it's a really good transition, because like you said, there's next steps here. So you don't have any others right now, but as you think of them, go ahead and feel free to type them into that question box, and I will make sure to share them with Ed as we wrap up. Okay, thanks.
Okay. All right, Kate, thanks. And that gave me a chance to kind of catch my breath a little bit and also take a few sips of water. Okay, so let's change the perspective now to green chemistry. Okay, so we know that there's a technical definition of green chemistry. When I present this to my class or to groups who may not have a background in green chemistry, this is what I typically use. Green chemistry is the science focused on making informed, evidence-based decisions and how we design, make, use, and dispose of chemicals and chemical products. And this, for me at least, makes a nice transition to talk about life cycle and how important life cycle analysis is to production and becoming in chemistry education, where we need to consider what our raw materials are from a chemistry perspective. How are we processing these materials? How are we scaling them up? What happens to these materials, these chemical products, over their life, and what happens to them at the end of life? Another nice approach in talking about green chemistry is risk analysis. The typical equation that we see for risk analysis, so that it's a function of the hazard of the chemical, how we are exposed to it, or how we are protected from exposure, and also who is the most vulnerable. So many of us know that limiting exposure is referred to as the command and control approach. The government regulations, not as much focus on reducing pollution, but cleaning it up, but on preventing our exposure, while green chemistry focuses on the hazard and reducing or eliminating the hazard. So if you eliminate the hazard, your risk becomes zero, and the exposure and vulnerability aspects become moot points. We have our 12 principles of green chemistry, which I'm not going to go through because I think most of the listeners are pretty aware of what they are. These are the guidelines we use for sustainable molecular design to produce these consumer products that are better, that are safer, that are cheaper. Green chemistry focuses on pollution prevention, benign by design, chemistry that is safer, cleaner, more efficient, minimizes the risk of release and exposure, important for people and society. Lower production costs. This is important for another aspect of social justice, where all people have access to chemicals and chemical products. And improve worker safety for the folks who are actually producing and working with these chemicals. An interesting site to mine for examples of where green chemistry is benefiting society is the US EPA Green Chemistry Challenge Awards, or the Presidential Green Chemistry Challenge Awards. And what I have here is just kind of a brief summary or overview of how what some of these winning technologies have meant in terms of reductions of hazardous chemicals and solvents, savings of water, because access to water is a huge issue in our world today, or many parts of the world, reducing the amount of greenhouse gases that are being produced, developing new catalysts using earth-abundant metals or using earth-abundant materials to go hopefully into some of our computer products and smartphones, making plastics from greenhouse gases, and reducing fertilizer nitrate leaching. So if we could connect these winning technologies and their impacts to the effect they're having on reducing social and environmental injustices, then I think we can make a case that it is implicit that green chemistry equals or is equivalent to or contributes to social and environmental justice. And I think this is one of the gaps we have, is how do we connect the outcomes of these technologies to dealing with some of these issues of social and environmental justice. So at this stage we're ready to kind of start wrapping things up, and let me start by how we're going to fill in some of these gaps, or what some of these gaps are from my perspective. I'm sure that there are many others. What other examples exist of social and environmental injustices of chemical exposure? What might be the relevant impacts of climate change? As I alluded to earlier, how does the accessibility to chemicals and chemical products connect with social and economic status as well as race? Is it truly accurate that we can say that it is implicit that green chemistry equals social and environmental justice? And as I argued on the previous slide, can we connect the technologies that have come through green chemistry to having been a way of solving some of these social issues? What future green chemistry technologies will contribute to correcting these disparities? We need educational resources, not only for us as practicing chemists and green chemists, but also in working collaboratively with colleagues from outside of our silos. And one of the things I'm hoping to do at the Green Chemistry and Engineering Conference in 2017 is to have a discussion or start a discussion on open educational resources, something that I've become particularly excited about. And this is more than just looking at online textbooks, free online textbooks for your classes, but actually engaging your students in developing lessons that go live, that are accessible, and that get improved and built upon semester after semester or year after year. And of course, there's research. I teach at a predominantly undergraduate institution. My research is with undergraduates. So we are looking to identify new databases, such as the EPA databases for relevant info, exposure data, and also from maybe at a somewhat higher level, developing and using personal sensor technology. Interdisciplinary is a key there for everything that I've been talking about. And finally, continuing the conversation. So for everyone listening, educators, practitioners, and students, we need to start talking about this topic, and from both an educational standpoint as well as an awareness. We have been engaging in dialogue on our campus. We've been reaching outside of our own disciplines and also had conversations with our community. Write articles for the Nexus blog. That's through the Green Chemistry Institute. Reach out and include your colleagues and students from outside of your disciplines. I've had research students from psychology, from sociology, and from social work who have worked in my research group. And also students and faculty, we can all make contributions at professional conferences. As mentioned earlier, Jane Wissinger and I, we run the Green Chemistry Theory and Practice Symposia. The next one will be at the ACS meeting in San Francisco. I would love to have a half-day session on the social and environmental injustices of chemical exposure. So please think about that and consider submitting an abstract. The deadline's coming up in 3 weeks. And finally, the Green Chemistry and Engineering Conference. It's going to be in Reston, Virginia, June 13th to 17th of 2017. I am hoping to run a symposium on green chemistry, social and environmental justice, theory and practice. We'll dig a little bit more into these issues, do that SWOT analysis with a panel of experts, and also talk about these open education resources and see how we might be able to start working groups and putting some of these together. So let me just close by thanking Beyond Benign once again, thanking everyone who's participated. Again, my email address and my Twitter handle. I'm more of a lurker on Twitter, to be completely honest. I do find that it's a great professional resource, though, for getting information that might take me longer to go through Google or other means. And most of my resources, as I indicated, have come through environmental health news. That got me started and helped me to lead to the primary literature. So I will close by leaving up here some homework questions for you all to think about. Hopefully those of you who will be coming to the Green Chemistry Symposia at ACS San Francisco and to the Green Chem and Engineering Conference in Virginia, if you're going to attend our sessions, please bring these questions with you. Think about the responses. Discuss them on your campus. And this will help provide a framework for how we might go forward with this discussion. So again, thank you very much, and Kate, back to you.
Great, thank you, Ed. I'm going to transfer this back. We have quite a few great questions from the audience, so thank you, and I am going to show the screen here. Okay, so a couple of questions from the audience were related to could they get access to the materials, and the wonderful thing about the webinar is that it has been being recorded, and so all of the supporting documents, upcoming webinars, registration links, all of that can be found at this link that I'm showing on the screen now, the greenchemistrycommitment.org, the resources Green Chemistry Webinar Series link. So you'll be able to find all of that there. But now I want to get to some of the questions that we have from the group. So
can I just interject something very briefly? Yes, so what I have sent to Beyond Benign is the actual PowerPoint for this presentation. So please feel free to use that if it's of any value to you. Also, I'm planning to develop a Dropbox site where I will be where we can share resources related to this and have accessibility to as many, open access to as many people who want or need it.
Terrific, thank you. And Ed, I did actually, in the GoToWebinar platform, it allows me to actually attach the PowerPoint as a handout. So if you scroll down and look at handouts, Ed's PowerPoint is already there, and you can download it directly now. Even before, if you are looking to use it immediately. We will also share it on the greenchemistrycommitment.org page as well within about an hour. So it will be there too. Okay, so now some of the really great questions. So we have one question, and it really just refers to accessibility of products, and this goes to what you had shared, Ed. But commonly household green products can be pricier and hard for low-income people to justify buying. And I'll just sort of wrap a question around that. How do you propose that we sort of tackle that as one challenge that is currently out there?
Yeah, that's a great point, great question, and thanks for picking that out, Kate. This is where we need to collaborate with someone who has a background in economics, someone who has a background in psychology. I don't, obviously that's not my background, but as supply and demand. I mean, as consumers want more of a product, that's going to lower the production costs. So, I mean, I agree. There are these greener products. The EPA even has a list of them, I believe, or greener preferences. But one thing I've benefited from in being on Twitter is collecting information on homemade cleaning products that can be made using inexpensive materials that you can get at the grocery store. Of course, vinegar, baking soda, and the like. So, but in terms of the more commercial products, I don't have a good answer for that. We do need an economist to help us out. I mean, I was thinking in terms of things like greener energy. Can that be priced low enough that it can be accessible to people in all parts of the world? Medicines and other pharmaceuticals, to make sure that those prices can be kept low enough and to be accessible to people. I mean, there's been a lot in the news just in the United States about the elevation in the cost of some medical products. That is an issue of social justice.
Great, thank you, Ed. And I also have another question here, comment first. So, hi Ed, thank you so much for introducing this important topic, and I wonder, what is your recommendation for implementing social justice topics in the more traditional chemistry curriculum?
Oh boy, that's a great question, and I actually had jotted that down because I had a feeling that was going to be asked. I don't have a good answer because we're all saying that our chemistry curriculum is so crowded right now. We have trouble just getting green chemistry into our curriculum. I will say that I am looking at, we are developing or working on this green chemistry education roadmap, which will hopefully outline what chemistry education might look like 10, 15, or 20 years from now, where we may be bringing in like life cycle analysis into our classroom. And as part of that, talking about the context of how chemicals are being used in society. And this is where we can emphasize the environmental and the social impacts. I think it's easier to bring these topics into non-major courses, but we also need to bring them into major courses. Here at BSU, I've certainly been bringing these topics in with my research students, with some of our upper level seminar courses. We also have freshman and sophomore seminar courses that all students are required to take, but there are, of course, there are only so many hours in the day. We can't teach all these new courses and reach all of our students. So this is a great question that groups of chemists green chemists need to get together and discuss. And please, pay attention to what is on the Green Chemistry Institute's webpage about the Green Chemistry Education Roadmap. There will be opportunities to provide feedback. This will be a topic of discussion at the ACS San Francisco meeting, and I'm guessing or hoping a topic of discussion at the Green Chem and Engineering Conference in June. I
Great.
think the development of case studies for education and these open education resources that we can share would be a great benefit to helping us integrate these topics into our courses.
Great. And I've got another question here, and this is a really good one. So related to your thought in question 3. So going back to your presentation, do chemists need to be advocates when thinking about social justice and green chemistry solutions?
Okay. That was at the beginning, I think, right?
Yeah.
Okay, to be advocates. Not everyone is good at being an advocate. I mean, I know that this is the way I can be an advocate, is to look at this from a academic standpoint, to do my research, to engage my students as part of their research, to consider the life cycle and the social impacts of the work that we're doing. I see that's a role that I think students can have. On a college campus, I think students can play a better advocacy and activism role, certainly than I can. I know that some of my colleagues out there, I think, are more vocal and are better able to get their points across than I can. But certainly, at least on a college campus, it's usually a lot easier for students to get the administration's ear and eye than the faculty are. But yeah, I'm certainly not saying that all of us chemists should go out there and be advocates, but I think from an educational standpoint, we can let our students know, let our colleagues know, and find ways through community outreach to talk to our communities about what these issues are, so that they're aware of them as well.
Great, and I've got one more question. It's a double question. So, have you much information about how chemicals move through the environment, and which chemicals are of concern from a health perspective? So this is a pretty big, broad one.
Well, the mobility of hazardous chemicals in the environment is a big concern. Wherever you have a hazardous spill, you need to know what is going on in terms of the movement of the soluble as well as the insoluble materials in the ground. Is it going to get into the groundwater? If it gets into the groundwater, where does it end up? I mean, this has been an issue in many parts of the countries where we have Superfund sites. That is certainly not my area of expertise. I mean, there's where you need collaborations between chemists, green chemists, and earth scientists to understand those factors. The second part of that question was about which chemicals are considered to be hazardous?
Yes. Which chemicals of concern from the health perspective?
Okay. Well, I think that's really depends on an individual person and depends on the environment that they are in. There is absolutely no simple answer to that. Every time we have a panel discussion about this here at BSU, somebody's always asking that. And how healthy are you as a person? Do you smoke? Do you spend a lot of time out in the sun? Do you drink alcohol? Do you tend to eat a lot of vegetables? What is your makeup from a genetic standpoint? And then it's hard to pinpoint any one chemical as having any particular effect. My grandfather was exposed to DDT. He passed away from bone cancer. There's no way of proving that DDT caused that. But many other members of my family and my community are perfectly healthy and have had long lives. He also smoked. Maybe that had a contributing factor there as well. So that my response in summing that up is usually work to have a healthy lifestyle. Work work to understand where chemicals are in the consumer products that we use and see what substitutes you have. For example, my wife and I, we stay away from plastics as much as we can. When we microwave things, we only use ceramic. We don't use plastic anymore. We stay away from plastic bottles that have BPA in them. And it's more to just to set an example to other people as well.
All right. Thank you so much, Ed. And right now, we'd like to announce the winner of the Green Chemistry book. So the winner is Zach Miller. And Zach, we will contact you directly after the webinar. We'll get your contact information and send you the book directly. So congratulations. And once again, we'd like to thank Ed for a fabulous presentation and for giving us a great model for integrating green chemistry, you know, and looking at how it, you know, these bigger picture issues of social justice. So thank you for listening in on our webinar. Recordings and supporting documents will be posted on the website, listed right on this slide. And please sign up for our mailing list in the bottom right-hand corner of the homepage. And this is where you'll hear more about when the upcoming webinars are going to be held at www.greenchemistrycommitment.org. So thank you again for joining us, and have a great afternoon.